My name is Dr. P.C. Patel, retired research scientist and guest faculty, professor, Parul University, Vadodara, Gujarat, India. At present, I am residing at Edmonton, Canada. So that today, the topic of my YouTube is the hard truth: why organic farming gives less yield and can India afford it? Evidence-based analysis. So you can see it is organic farming. Here it is a natural farming, and here indicated nutrient management, visual structures and pacing. Can India feed its growing population using only organic farming? The scientific data reveals a surprising answer that every farmer and student must know. Storytelling: we have the data into a narrative, the problem, yield gap, the investigation, global and Indian studies, the moment why the gap exists, the solution, integrated nutrient management based practices, the call to action. Introduction and motivation: a vibrant tall crop with a plus chemical icon. So it is a conventional farming. Integrated nutrient management practices, waste hill plus healthy soil. Organic farming and natural farming, good looking soil with a positive organic icon. Here we are comparing projection for India 2050 and 2065 population and total food grain. So you can see that summary table in 2050 the population of the India is 1650 million, whereas the requirement of the food is 420 million tons. Then per capita water availability 900 BCM, billion cubic meter. In 2065, the population would be 1800 million and the requirement of the food grain production 450 million tons. So if you follow the organic farming, either natural farming or organic farming, then it is very difficult to produce more food grain for the ever increasing populations during 2050 and 2065. Background and definition. So organic farming, so it is a symbol of the organic farming. Here we cannot use the synthetic fertilizer. Then use of organic manures, compost, biofertilizer, avoidance of synthetic chemical fertilizers and pesticides. Natural farming, key point, zero external input. So it is a icon of the natural farming. A variant emphasizing zero external input, reliance on the indigenous natural substances, as for example Jeevamrutha, Panchagavya, on-farm biomass. It is also called as zero budget farming system. Then third one, integrated nutrient management. So key point, balance use of organic plus chemical plus biological means biofertilizer. So a system that combines organic, chemical and biological inputs like biofertilizer based on soil testing and crop requirement to optimize both yield and soil health. So integrated nutrient management, we are adding the organic as well as chemicals as well as biological, that is biofertilizer. In natural farming, we are not adding the synthetic fertilizer, or even we are not adding the organic manure or organic pesticides. Whereas in organic farming, we are not adding the chemical fertilizers, but we are adding the organic manure, compost, biofertilizer or biopesticide to control the insect pest. In this slide, we are comparing comparison of crop productivity under different farming system. So, organic farming, natural farming and integrated nutrient management. So, I told that nutrient source, organic manure, compost, biofertilizer, Jeevamrutha, cow dung, urine based inputs, combination of chemical fertilizer, farmyard, compost and biofertilizer. Then second aspect, nutrient availability, balance and timely nutrient supply. So, in organic farming, slow release may not meet peak crop demand. Then natural farming, very slow nutrient release, often insufficient. Integrated nutrient management, balance and timely nutrient supply. Third aspect, soil fertility build-up. In organic farming, improves slowly over years. So, in organic farmer, nutrients are built up, but it requires time. Natural farming improves very slowly. And integrated nutrient management maintenance and enhance fertility efficiently, because in this system we are adding organic, inorganic as well as the biological, means biofertilizer. Then fourth aspect, crop yield level, it is very important. 20 to 30% lower than integrated nutrient management or conventional. In natural farming, 30 to 40% lower crop yield as compared to integrated nutrient management and conventional, whereas INM higher and more consistent yields. So, we are sustain the crop productivity in integrated nutrient management. Then soil microbial activity aspect, high but nutrient mineralization slower in organic farming. In natural farming, high natural diversity but low nutrient turnover. Whereas integrated nutrient management, moderate to high with sustained microbial activity. That is why we are getting more crop production in INM as compared to organic farming and natural farming. Then last one is input cost, moderate to high depending on organic input. Natural farming very low, INM moderate. So in this slide you can see the different pictures. So it is a Indian farms cultivate the land through the block. Then it is a organic farming. Then in India it is a natural farming systems. So it is a Jeevamrutha. Then it is a integrated nutrient management. So here we can use the organic manure as well as the chemical fertilizers as well as the biofertilizer for improving the soil fertility and sustainability. So here we are talking about the natural farming. So Panchagavya preparation. So cow is required, indigenous cow is required. So it is a गिर cows. Then जीवामृत बनाने की विधि, जीवामृत preparation. Then farmer prepare compost. So compost. Then soil sampling is very important before planting of the crop. we should have know the initial nutrient status, and accordingly we should have to apply the chemical fertilizers or organic manure in the soil as per the soil test value. Essential requirement for sustainable crop productivity. So in first column key factors, second column requirement, and third column purpose or benefit. So first, soil testing, regular soil testing before sowing and after harvest. So what is the purpose? Identify nutrient deficiency, soil pH, imbalance, and need for amendment. Second column, nutrient balance. Apply nutrient based on crop need and soil fertility. Prevent overuse or deficiency, maintain long-term soil fertility. So at present, you know that farmers are not carried out the soil analysis and they are applied the nutrient as per his wish or the advice of the fertilizer merchant. Resulted in they are adding the nutrient imbalance in soil. So resulted in, although they are applied a huge quantity of the chemical fertilizer or manure, but they are not obtain the higher crop production. So balanced nutrition is very important for higher crop production and sustainable soil. Then third one, microbial health. Enrich soil with organic matter, compost, biofertilizers. You know that the food of the microorganism is organic matter. And if we are not adding the organic matter, then how the microbial survival? So farmers are mostly at present reliable on chemical fertilizers and they are not adding the manures, resulted in the population of the microbial has been declined, and again they are apply the excessive dose of the chemical fertilizer and excessive concentration of the pesticide and fungicide and herbicides, resulted in we have killed the population of the microbial, and also we have killed the earthworm, and earthworm is the friend of the farmer, but farmer has now killed the earthworm also. Then what is the purpose benefit? So when we add the organic matter in soil, that it improves soil structure, it improves the water holding capacity and nutrient retention. Means whatever the nutrient we apply to the organic sources or inorganic sources, but it has been not leach out, but it has been stored in soil in a proportion, and slowly it is available to the plants. Then last one, integrated approach. Combine organic and inorganic sources. So we are doing these things in integrated nutrient management. And what is the purpose or benefit? Maximize yield with sustainable soil health. So healthy soil, balanced nutrients, plus active microbes, plus regular testing. Summary message: healthy soil, balanced nutrient, active microbes, and regular testing. This slide shows the meta-analysis and global evidence. So here Gopinath and his co-worker 2023 indicated nutrient management, higher yield and economic return, soil nutrients. Whereas in pure organic, either organic farming or natural farming, lower yield and lower return, variable soil health. So this study compares long-term effect of conventional, integrated and organic फार्मिंग सिस्टम in इंडिया. हमने कई वर्षों में फसल की उपज, मुद्रा, स्वास्थ्य और सूक्ष्म जीव गतिविधि का अध्ययन किया. So it is a Super Tennis Coworker 2012 finding. In conventional, they are getting the 100% yield. Conventional farming yield. In organic farming, they are getting the 75% yield. So you can see that the global average gap is 25% yield gap. So conventional farming system means integrated nutrient management system produce higher yield as compared to organic farming, either it is organic farming or natural farming. Suppose I will give the example. Suppose you take the wheat crops and the crop productivity is suppose 4000 kg per hectare. So in conventional farming or integrated nutrient management, we are getting 4000 kg per hectare. Whereas in organic farming, natural farming, we are getting 3000 kg per hectare. So there is deficiency of the 1000 kg grain wheat per hectare, means it is 25% yield gap. So integrated nutrient management system perform best in sustaining both yield and soil quality, because in integrated nutrient management we are adding the organic manures as well as integrated as well as the uh, chemical fertilizers and biofertilizer also. Indian studies, Kumar and his co-worker 2025 reported that T7 FYM plus PGPR plus 3% foliar Panchagavya reduced yield penalty in maize from 11.9% in year 1 to 8% in year 3. So here T1 treatment, that is controlled 100% recommended dose of fertilizer to fodder maize crops, 100% recommended dose of fertilizer to berseem crop, plus 100% recommended dose of fertilizer, recommended dose of fertilizer to cowpea crop. So T1 treatment of maize produce the higher grain forage yield over other organic treatments from T2 to T7. But T7 here they are talked. So also T7 improves soil organic carbon because it is organic treatment for 0 to 15.2%, microbial population 54.8 to 119.3% increase, and enzyme activities 103 to 187% over baseline. This system highlights the importance of integrated nitrogen management in organic systems, either farmyard manure or PGPR or Panchagavya. So it improves the organic carbon, then microbial activities as well as the enzyme activities. So this study highlights the importance of integrated nitrogen management in organic systems, reducing reliance on synthetic fertilizer while enhancing ecological sustainability. But here it is interesting to know that T1 treatment, when we are using the 100% chemical fertilizers, then we are getting 11.9% higher grain forage yield of maize in first year and 8% higher grain forage yield in third year. So here you can see that plant growth is also greater in T1 treatment. Either it is maize crop or berseem crop or cowpea crops. Then cowpea equivalent yield also is greater. Then total digestible crude protein is also greater when we are apply 100% recommended dose of fertilizer to each crop, each fodder crop, to maize, berseem and cowpea. So narration, so while the soil gets healthier In organic farming system T6 to T7, the yield does not fully catch up, but it cannot fully catch up from T6 to T7 treatment. So this is the core of the dilemma. Similarly, Iqbal and his co-worker 2020 reported that combination of 30% nitrogen from poultry manure or cattle manure with 70% nitrogen from chemical fertilizers, that is urea. So they have given 30% nitrogen through poultry manure or cattle manure, but 70% nitrogen through chemical fertilizer urea. So it is a promising option for improvement of soil quality and rice grain yield. Furthermore, our study provides a sustainable nutrient management plan to increase rice yield with high nitrogen use efficiency. So high nitrogen use efficiency we are observing in integrated nutrient management, mean organic plus chemical fertilizers. So in treatment you can see here also, here 60% cattle manure and 40% chemical fertilizer. Here 30% poultry manure or cattle manure and 70% chemical fertilizer I have told. So here we are getting grain yield increase 15%. Here we are increased 10%. So narration, these mechanisms help explain why yield gaps occur and why integrated or hybrid system often outperform pure organic or natural system under realistic conditions. So when we follow the organic or natural farming system, but we are not achieve yield as integrated nutrient management. So here I am explain mechanisms why yield differ, because there are three type of systems: chemical fertilizers, organic manure, and a part C, integrated nutrient management. So it is a conventional farming. So first we look the fast predictable nutrient release. Nutrient becomes immediately available to the crop root system, because here we are applying the nutrient in chemical form. So nutrients are released fast to the plant, available fast to the plant, to the root system. Whereas in organic manure, slow microbe dependent mineralization, nutrient bound in organic matter require microbial decomposition before becoming plant available. So it requires time to release the nutrient to the soil. Then integrated nutrient management, INM. Here integrated means combined strategy, organic plus inorganic plus biofertilizer. So fast release chemical fertilizers meet the immediate peak demand, plus slow release organic provides sustained supply, plus biofertilizer microbes accelerate organic matter breakdown and improve nutrient use efficiency. That is why integrated nutrient management gives higher crop production as compared to chemical fertilizer or organic manure, because here we apply the nutrient in organic form, and through the microbes, means through the biofertilizer forms. Then second point, high synchrony nutrient supply aligns closely with peak crop demand, so immediate uptake is maximized. So you know that farmers are apply the chemical fertilizer in split dose. So when there is a peak period of the crop, then they uptake the nutrient from the fertilizer. So there is no any deficiency in chemical fertilizer, means conventional farming. In organic farming, lag in nutrient availability. During peak growth phases, the crop demand may outpace nutrient release, leading to unmet demand is equal to yield penalty. So we have seen the research work that we have observed the penalty in yield in organic farming or natural farming as compared to the integrated nutrient management. Then we will see what is the role, what is the happen in integrated nutrient management. Optimize synchrony and balance. Nutrient release matches crop demand more closely across growth stage, reducing yield gap and losses. So here there is no gap in demand of the nutrient by the plants. So the yield is not reduced. So we are achieving the maximum crop productivity. Then last one, limited long-term soil benefit, minimal build-up of organic matter, microbial biomass, possible soil fertility decline over time. So there is a build-up of organic matter, although we are apply the chemical fertilizer continuously, but long time there will be depletion of the soil fertility. So at present we are observing that conventional farming there will be decline crop productivity because I explained in another video that the population of the microorganism has been declined. And what is the role of the microorganism? Whatever the nutrients present in the soil unavailable form, that they convert available form by the microorganism. So the population of the microbial it declines significantly in chemical farming system or conventional farming system. Then organic manures or organic farming optimize synchrony and balance. Nutrient release matches crop demand more closely across grow. And dual benefit, high immediate potential and improve because we are applying the nutrient in organic and inorganic and through the biofertilizer. Here you can see high organic system release nitrogen. So organic matter decomposition, organic residue like compost, manure, crop residue enrich soil organic carbon and nitrogen. Microbial nitrogen conversion, soil microbes convert organic nitrogen to plant available forms, ammonium or nitrate. So you know that when we are apply the manures, then plant will never take the nutrient in organic form, but it converted into inorganic form. So here suppose we talk about nitrogen, then it converted to ammonium and nitrate. So plant take nitrogen in ammonical form or nitrate form. Similar to true for the other nutrients. Then slow and synchronized release. Nitrogen released slowly, matching crop growth stage, reducing leaching loss. So the advantage of the organic farming that nitrogen released slowly, then matching crop growth stages, and due to addition of the more organic matter or conversion of the more organic matter in organic farming system or natural farming system, there will be less leaching of the nutrient. Whereas in chemical farming, conventional farming, there is a more leaching loss of the nutrients. So summary, nitrogen is mineralized slowly from organic input by microbial activity. So in organic farming system, the nitrogen is mineralized slowly, whereas in chemical farming system or conventional farming or integrated nutrient management, it is fast. So nitrogen is mineralized slowly from organic input by microbial activity because we are there is more organic matter in the soil in organic farming system. So obviously more microorganism population in the soil. So it helps the mineralization of the organic matter into inorganic forms for the ability of the nutrients like nitrogen, phosphorus and so on. So soil health improvement. Organic management significantly improves soil organic carbon by 38%, nitrogen by 20% and microbial by 45%. ऑर्गेनिक प्रबंधन मुद्रा की उड़ता और जैविक गतिविधि को मजबूत करता है. माइक्रोबियल एंड एंजाइम एक्टिविटी बूस्ट. सूक्ष्म जीव और एंजाइम गतिविधि ऑर्गेनिक प्रबंधन में सबसे अधिक देखी गई है. So now we look the research evidence based on the research paper. Chemical fertilizers provide rapid nutrient availability that often meet peak crop demand but offer limited long-term soil carbon and microbe benefit. Organic manure releases nutrients slowly via microbial mineralization. If mineralization is not synchronized with peak crop demand, yield can be reduced early in the season. So in organic manure, if mineralization rate is not synchronized with the peak crop demand, then we observe deficiency of the particular nutrient in organic farming or in natural farming system. Then third one, integrated nutrient management, chemical plus organic plus biofertilizer frequently increases yield and improves soil health versus single source strategies. Reported yield gains 1 to 66% across system. Case studies, comparative experiments. Kumar in his coworker 2025 reported that T7 FYM plus PGPR plus 3% foliar Panchagavya reduced yield potentially in maize crop from 11.9% in year 1 to 8% in year 3. So that we have discussed earlier. Also T7 improves soil organic carbon 4.0 to 15.2%, microbial population 54.8 to 1119.3% increase, and enzyme activity 103 to 187% over baseline. So in organic farming system, the organic carbon is increasing, microbial population is increasing, and enzyme activity is also increasing. But yield penalty in maize crop from 11.9% to 8% in year first and in year 3 respectively. Another example, in impact of organic and integrated production system, Gopinath and his co-workers, they reported that integrated system gave a higher yield and better nitrogen use efficiency compared to pure organic system. So Gopinath reported that integrated system gave higher yield and better nitrogen use efficiency as compared to the pure organic system. And therefore, we are getting low crop production in organic farming system as compared to integrated nutrient management. Then, from Ryer and coworker 2025 recently, long-term organic versus indicated cotton system in central India. Over multiple years, organic had lower yield and net returns compared to system using integration. So the BT cotton conventional system saw the highest mean annual gross margin 11% higher yield than organic systems. So from that we have concluded that integrated farming system or integrated nutrient management system, either you apply the nutrient through organic, inorganic and biofertilizer, we produce the higher grain yield, fodder yield and higher net return as compared to the organic farming system. So we have discussed. So on the basis of the recommendation and best practices, so pillar 1, test and diagnosis, start with soil and plant testing, no guessing. So it is a soil testing is required. I repeatedly told to the farmers before planting the crop, farmers would have to carry out the soil testing, and as per the soil needs initial status, we should have to apply the nutrient in soil. Then it is a diagnosis. Then pillar 2, integrate and balance. Combine organic plus chemical plus biological input like biofertilizers. Use biofertilizer PGPR mycorrhiza to boost efficiency. So integrate, and here the balance icon. So you can know that what is integrate. Integration is very important. Not only one chemicals or organic, but you integrated both chemicals as well as the organic. That is integrated nutrient management. Then third pillar, monitor and adapt. Track yield and soil health yearly. Manage other limits, water, weeds and soil pH. So when you grow the crop, then you monitor the crop growth every 15 days, 10 days. Then whatever the lacuna in the soil or plant, then we should have to correct it. So we get definitely higher crop yield and also maintain the soil health for a longer period. Future research and policy suggestion, frame this as a collaborative call to action for different stakeholders, for scientists, long-term trials in different agro zones, for universities, industries, develop crop-specific integrated nutrient management protocols and economic models, for policymakers, subsidize soil testing and biofertilizer, train extension workers, for farmer, join on farm trials, form cooperative for bulk compost purchase. Last one, summary and call to action. Organic farming, great for soil, but mind the yield gap. So when you grow the organic farming system, then your soil will be improved, but you keep in mind that there will be yield gap 25-30% as compared to indicated nutrient management. Then indicated nutrient management, it is icon. The smart balance, apply the nutrient as per the soil test value. You get definitely high and also healthy soil. You keep the soil healthy also because we are applying nutrient in organic, inorganic and biofertilizer form. Then foundation, when we prepare the house, then we keep strong foundation. Similarly, it all starts with soil testing. So without soil testing, If you add the nutrient and other things, seed, fertilizers, but you forget the soil testing, then you will lose the crop productivity. Health impacts of excessive agrochemical use, indicated nutrient management, and conventional farming system generally produce higher yield than organic and natural farming. Excessive use of fertilizers and pesticides contaminate soil, water, and food, leading to chronic health problems in humans and animals. Safe and balanced application as per State Agriculture University recommendation is essential for sustainable farming and public health. So take away slides. Organic, sustainable, but yield gap. So it is a highlight. Indicated nutrient management, balance between yield plus soil health. And soil testing, foundation of success. So I have seen previously slide, soil testing is foundation of success. Then last one, final call to action. For more evidence-based guides on sustainable agriculture, scan the QR code to subscribe to our channel. Let us build a productive and sustainable future together. So myself, Dr. P.C. Patel, consultant, retired research scientist, Anand, Agriculture University, Gujarat, India. My WhatsApp +91 9909022 Email patelpc12@gmail.com. So I have prepared the YouTube channel. So it is my QR code, and it is my YouTube channel @PCP Anand _soil health. So thank you very much, and please do not forget to subscribe my channels. And if you have any problem, then you can contact me, or you need my consultant service, then also you contact me. I have 50 years experience, and I did PhD in soil science and agronomy, and I serve 50 year service in Anand Agriculture University, Patel University. So thank you very much.